And while experiencing the error, we are having different kinds of errors here. Input quantity, these are all the major errors we experienced, right? So we will experience. So input quantization error, coefficient quantization error, product quantization error. So input quantization error in the sense the conversion. Normally the sampling process is for converting the continuous time input signal into digital signal. So the conversion of continuous time input signal into digital value produces an error which is known as input quantization error at the input side itself. This error arises due to the representation of the input signal by a fixed number of digits in the analog to digital conversion process. And coming to the second category, coefficient quantization error. So here the filter coefficients are going to be stored here. The filter coefficients are compared to infinite precision if they are quantized, right? We are bringing the infinite value to the finite value. If they are quantized, the frequency response of the resulting filter may differ from the desired frequency response. Naturally it will happen, and the poles of the desired filter may change, leading to instability. In the sense, suppose before doing my quantization procedure, my pole locations are, for example, my pole locations are 1 and 3, for example, plus 1 and plus 3, right? So sorry, if you comparing with your control system subject, then you can have this kind of the stability concept you can able to understand. If all my poles are lying on the left hand side of my S plane, then my system is a stable one. If it is on the right hand side, then my system is a unstable one, isn't it? So if I am here, in the case if I am designing my filter, all my poles are lying on the left side of my location or left side of my S plane, right? So in that condition, my system is a stable one. But due to the quantization procedure, the pole location will get shifted, right? So in that time, suppose if one of my pole will shift it to the right hand side of my S plane, then my system will move from stable condition to the unstable condition. It may happen, it will happen, right? So the stability, the condition, the system stability itself will get affected if we are experiencing the coefficient quantization error while doing for the quantization procedure, right? While doing the quantization procedure, we will have this kind of error, coefficient quantization error. This is a very important thing, right? The system stability will get affected because of the shifting in the pole location. And coming to the last category, the product quantization error. So it arises at the output of the multiplier. So if you are doing the multiplication process, then after doing that, after arriving the result, then if you are doing the quantization procedure, then if you are, that is either doing the truncation procedure or doing the rounding procedure, naturally our result will get deviated from the original one. So the difference between the original one and the quantized one will be the product quantization error. So when a B bit data is multiplied with another B bit coefficient product, so we will have one result. So that should be stored in the B bit register. The capacity of the register is B bit. The multiplier output must be rounded or truncated to B bit, whereas our output will be 2 into B bit, whereas our capacity is B bit. So we have to round it. So this is otherwise known as overflow or round off error. So we will have these kinds of errors in the quantization procedure.